Welcome. In this video, we're going to determine whether this series converges or diverges using the alternating series test. So remember, the first thing we want to do is show b sub n is decreasing, and our series a sub n is going to equal -1 to some power times b sub n. So that's what I mean by b sub n. And the second thing we want to show is that the limit as n approaches infinity of b sub n equals 0. Okay, so let's look at number 1. So b sub n is equal to 1 over n. Now what is the next term? B sub n plus 1, well that's 1 over n plus 1. The denominator got bigger and the numerator stayed the same, so we know that the next term is certainly decreasing. All right, now let's look at number 2. Let's look at the limit as n approaches infinity of the sum from n equals 1 to infinity. Oh, excuse me, what am I doing? Of 1 over n. So just our b sub n, that's certainly 0. Okay, so what have we established here? We've established that this series, this alternating harmonic series, converges by the alternating series test, which you'll often see written in shorthand as AST. Now, is this convergence conditional or is it absolute convergence? For that, we need to look at something else. All right, let's go ahead and look at number 3. Is this convergence absolute convergence or conditional convergence? Well, in that case, let's look at the sum from n equals 1 to infinity, remembering that in our case, a sub n is equal to -1 to the n minus 1 power over n. So let's look at this absolute value of this series. Well, that's equal to something we should recognize. This is a harmonic series, which diverges. Okay, so what have we learned? We know it converges by the alternating series test, and this convergence is conditional. All right, folks, keep calm and math on.